Okay, this is part 2 of our video series 3 about availability management within Bazefield. In part 1, we went over the background of availability management, why it's important, and how you can configure availability systems in Bazefield. We're now going to talk about the process of how allocations are generated automatically by the system and how users can influence those by allocation rules. So in terms of the automation of this process, it's shown here in this slide. The critical part is to note about allocations is allocations can be triggered by any event or any piece of data in the system. Typically, they're triggered when new alarms or new events come in on the asset, or if operation states change. But technically, any process data, any calculation you can configure to trigger the allocation to potentially change and update the categories of the said allocation. And we'll go over this and how you can kind of make these different triggers. Typically, event codes are the most popular trigger because when a new event code comes in, you want the allocation system to check if the existing allocation needs to end and if a new allocation needs to begin because of that new alarm that has indicated a new state of performance. That prioritization and that whole logic, which I just described, is encapsulated in allocation and category rules. So these rules are like a series of, a checklist more or less that our algorithm and our system will go through, and it will check if each rule is met, and if that rule is met, then it will essentially do something. And I have examples on the next slide of what really, from a real world perspective, what does that mean? Once an allocation is started and ended in this process, allocation properties are then automatically calculated. So an allocation property is a snapshot or an aggregate of a certain tag within an event. So things like lost energy, production, you want to be able to measure lost energy from time A to time B when that allocation started to when that allocation ended. Finally, the last step, which we'll talk about in the subsequent videos, is the process by which users can edit the allocation categories and then use the allocation statistics application to report on losses in their fleet. Let's go over the triggers first. So the triggers are what starts this whole process. And again, a trigger is any combination of a calculation or an analog signal, an operational state, or an event code. So typically the most popular one is when a new event code comes in on an asset, we set up an alarm-based trigger. And that alarm-based trigger will start to then evaluate the rules to see, hey, does my allocation need to be updated? Does it need to be changed? Does it need to be modified? But there's numerous ways you can configure these triggers. You can add multiple triggers. So say, for example, you want to trigger the system when a curtailment set point changes, and you want to check if the asset is not now curtailed. That level of triggering can also be done. So the trigger is just what kind of turns the system on and says, hey, this machine has a trigger that's just come in based on your configuration. Now go check my rules, okay? Now what are the rules? To give you some, they're a little abstract unless I kind of write them out like this. So rules is a checklist, which each one has an order, and they're evaluated in the order provided. So for example, one allocation system could have a series of 4 rules. The first one being, let's say in normal speak, let's say the asset is currently allocated in a non-generating category, i.e. the asset is down, but let's say an event code with a full performance categorization becomes active. So this means the machine is down, but now a new alarm code with telling me the machine is running is operational. From there, the system will then act on the category rule and the existing allocation of the outage and switch to a full performance state. And vice versa, let's say if the asset is currently allocated to a full performance state, but an event code with that's associated with a downtime comes in, then the categorization rule, if this returns true, will switch it from a full performance to an outage. So these rules can help you prioritize also different types of stops. Let's say you can write a rule that says if the asset is down because of a fault, but a grid stop comes in, then I want the grid stop to take over. That is done through our allocation rules and the custom triggering that you can set up as a kind of an example here. And that's what I just showed here or so I just spoke about is this slide here. Just going over the concept of properties visually. At the end of the day, what the triggers and the rules do is every second of your asset operations will be categorized by one or more allocation categories based on the events. From there, the system then needs to automatically calculate what we call allocation properties. Allocation properties are just snapshot aggregates divided into the allocation periods. So let's say we had 3 allocations at times t0 to t3. And let's say we had a lost energy property we need to calculate. The system will then go out to, let's say, the wind speed or the irradiance. It will query it from point t0 to t1, time average it, and then do the property calculation. So it's really an aggregate of any domain point within an allocation period. That's what an allocation property is, and that's automatically calculated by the system. So now that I've hopefully not confused you too much, let's go into Bazefield where these rules and triggers are set up. Okay, back in our portal, let's show you where some of these allocation rules and triggers live, and basic explanation of kind of what they mean. This is mainly for experts. You can do a lot of damage if you don't know what you're doing here. So we always recommend you to potentially consult with a Bazefield support engineer if you have a very complicated situation you're trying to automate, because you can do a lot of damage and ruin an allocation system quite easily. You can find the rules and triggering, again, in your administration, configuration, allocation types. And for a first simple one, I'm just going to show you a demo, let's say a PV allocation system. So if I click this, this shows up some basic PV categories in which I want to track my losses. And I've gone through some of my PV inverter models and I've updated the events and categorized them to this generic set of classifications. And we showed that process in the previous video, how you can update domain models, change categories, re-upload them back to the portal, and have your domain model and your alarm templates change when you need to update them. Now, the other part that you can influence are the rules and the triggers. So we'll first talk about triggers. In this case, triggers are flexible ways where you can either, again, initiate the allocation system to trigger either by alarm or by tag. The most common way and what we recommend is by alarm. So this is saying whenever an inverter that is mapped to this standard has a new alarm or event come in, it will start the system and then go through the series of rules to see if that asset needs a new allocation or if the allocation needs to be updated or what have you. So all we're saying here is we're only using alarm-based triggering for this asset. If you really want it to get complicated, and this is something usually our support engineers might help you do, is you can actually set up more than one trigger. So say you want to trigger on a tag and an alarm. You could technically choose an invert, or you can choose the model you want to apply it to. You can say like a tag, and then you could type the tag name. So this could be, for example, the trigger tag could be a curtailment set point for the site. So if that curtailment set point trigger changes, which I think it's just called curtailment set point, just hit add. Now I have both a tag and alarm-based trigger. So now I'm saying, well, if this tag changes value, or if an inverter receives a new alarm, now I'm going to check my rules to see if things need to change. Okay, so that's how you can set up triggers. A trigger is just an initiation to check the rules. The rules are really where the logic is embedded about what the system does when it receives a new trigger. So really, this is probably the most simplest configuration of an example rule set. And again, we install these rules for you, and we have default set of rules that we've tested with different manufacturers that we think work best, but super users always like to get in here and try to make their own rules and tweak these. And again, this is an expert only situation. So for this allocation type, for these inverters, what I've done is I just set up 2 rules. The sort order describes at which part of the algorithm will be executed. So the lower number wins out. So when a trigger occurs, the system will first evaluate this allocation rule. So it's saying a trigger came in, the set point changed, or an alarm came in. Does the inverter have an active alarm to allocate? What that means is, what this rule does is, it looks at the domain model and it says, okay, alarm code 23 is active, I'm gonna look at my inverter domain model. I see code 23 has category X associated with it. So that rule would return true in that case because that alarm was categorized. If it returns true, when a rule returns true, it then runs the categorization rule. And in this case, all I'm saying is if there is an active alarm with a category, just get the category from the rule result. So I'm saying event code 22 came in, it has a category of grid outage. All I'm saying now is change the allocation status to grid outage. That's all this rule is doing. Now, let's say a trigger comes in, let's say a curtailment set point changes. It's going to evaluate now rule 0 again, and if it doesn't have an active alarm, let's say if the inverter doesn't have any active alarm, it will return false in this case, and it will march to rule 1. And rule 1 says, okay, if it doesn't, this explanation point, if it doesn't have an active alarm to allocate, then do this. In this case, that would return true in the case that there were no active alarms. And when this happens, I'm telling it, get the full performance category. So this will go to my category sets, and it will get the classification that is basically the full performance state. So these are just, again, a checklist that will automatically be processed every time a trigger is fired. The first one that returns a value of true from an allocate rule, the category rule will then be executed. So this is a very simple two-step example. Just to show you, we're not going to walk through the whole set, but our default setup for wind turbines is quite complex because there's a lot of cases we really need to evaluate. So if I walk into the GADS performance rules, I'm going to look at the rules that pertain just to, let's say, a GE system. You can see I have a series of 10 or 20 different rules with different conditions that the system uses. And not to walk through all of these, but this just goes to show we can catch pretty much any edge case and any prioritization that needs to occur. So even if you have, let's say, the machine in a fault, but a maintenance code comes in, you want the new maintenance code to take over and start a new allocation, that's what these rules would be written to do. And when you write a new rule, it's usually useful to give it a nice description, to give it kind of a physical, somebody looking at this, an intuition of what's happening. So like the first rule for us is if the latest event has a full performance state, then switch to that. And that's what the description is basically saying. So that's kind of a quick look into rules and triggers and how they help decipher whether or not new allocations need to be generated and when allocations need to start and when they need to end.